In this video, we're going to talk about analyzing graphs of functions, part 3. I'm going to notice, let me put it in. Graphs of functions, part 3. We're going to talk about end behavior and symmetry. So if end behavior takes too long, I'll make another video for symmetry. But let's first talk about what in the world do I mean by end behavior. Let me just draw you a few examples of graphs really quick. So, let's say I have a graph of a cubic function. The ends of your graph are literally these ends. So like we're going to talk about what are those doing? Where are they headed? What direction? If we have a graph that goes all over the place, we're just still talking about the ends of our graph. So these are the ends, the little arrows are right there. So even if we're just talking about a basic line, this is still one end of it, and that's the other end of it. So we're going to talk about end behavior. What are the rules for end behavior? So here are the basics. The good news is there are only 4 possible end behaviors of polynomials. So either your graph will act like a positive even function, which is like a basic parabola graph, and it will go what we call up, up, are the sort of short-term words for it. And then it could be a negative even function, so it looks like a downward-facing parabola. So any negative even function would behave the same way this basic quadratic graph behaves, and it would go down, down, we call it. Then we have positive odd functions. So anytime you have a positive function that's an odd degree, meaning like a cubic function or something with a 5th degree polynomial, those are odd functions. And it would behave like this one, which would mean it starts down and it ends up. And then we're going to talk about this other writing in just a second. Then if you have a negative odd function, so like any kind of cubic function or something with a 5th power or a 7th power, it would behave like this one. So it would go up on the left and down on the right. So what we do, I do anyway, is I think of it as the basic setup of your quadrants. If the end of your graph points toward a particular quadrant, it's going to behave very similar to how this basic setup was when you first learned about the coordinate plane. If it points toward quadrant 1, then that end of your graph is going to head toward a positive value for x and a positive value for y forever. And if it points toward the second quadrant, your x is going to be always headed toward a negative value, and your y will always be headed toward a positive value, and so on. So keep this in mind as we talk about the rest of that writing. So what I was saying right here is if your graph is positive and it's even, it'll always behave like this little graph right here. So this end of my graph, so like that little, let me grab a pencil, that end of my graph right there is saying as x approaches this first quadrant, which is positive, positive, x is always going to be headed toward positive infinity, and y will also be headed toward positive infinity. So we say, as x approaches positive infinity, y approaches positive infinity. That little arrow stands for the word approaches. Then we say on this end of the graph, it's headed toward the second quadrant. So your x value is negative and your y value will be positive. And so in better terms in math, we say as x approaches negative infinity, y approaches positive infinity. But it's very much like that second quadrant we looked at over here. It behaves that way because of where it's pointing. So over here, the same thing kind of happens. This one is approaching the 4th quadrant, so that's positive for x and negative for y. So we say as x approaches positive infinity, y is approaching negative infinity. We put that into more formal writing. And then as it approaches the 3rd quadrant, x is negative, y is positive. we say as x approaches negative infinity, y approaches negative infinity as well. Oops. Sorry, trying to think and talk and write all at the same time. Those are both negatives. So as x approaches negative infinity, it's going to the left. Y also approaches negative infinity because it's going down. So same thing here. When you have a positive odd function, it's going to go up on this end and down at the beginning. So down, up is the basic way to remember it. And we say it's approaching this first quadrant up here. So as x approaches positive infinity, y does the same. And over here, it's approaching the third quadrant. So as x approaches negative infinity, y also approaches negative infinity. And then if it's a negative odd function, it starts up and then it goes down. So in the second quadrant, x is negative, y is positive. So we say as x approaches, I think I put them in reverse order. So as x approaches negative infinity, y approaches positive infinity. And then over here, this one is positive, negative. So as x approaches positive infinity, I usually write that one first. Y approaches negative infinity. You don't have to put them in that order. I just typically put the x being positive first in my writing to keep it consistent. Okay, so on the next page, we have some examples. Here they are. So let's practice. So when we look at this first graph, we see that the graph is headed off up here into this first quadrant. So it's going to be positive for x and positive for y. So we would say as x approaches positive infinity, y also approaches positive infinity. And then on this end of the graph, it's also going up. So this was up, up, up is what we call it, because it's the ends of our graph are both going up. And it's in this second quadrant. So as x is negative, y is positive. So we would say as x approaches negative infinity, y approaches positive infinity. So the words up, up just help you remember what this looks like. We really want you to be able to write this formal statement about it. That just helps you to remember what the basic graph would look like. Then this graph has already been drawn, and it's going down, down. So it's going down toward the fourth quadrant. So that's where x is positive and y is negative. And so we would say as x approaches positive infinity, y approaches negative infinity. It's very directly related to that. And then as this end of the graph approaches the third quadrant, so here's quadrant 1, 2, 3, 4. It's going toward the negative, negative signs for x and y. So we'd say as x approaches negative infinity, y is also approaching negative infinity. Okay, let's look at two more. So this one is behaving like an odd function because the ends of the graph are doing different things. So this one's going up, down. So this is a negative odd function, which we can tell by looking at it. It's negative, and it has a fifth power, which makes it odd. So we can see that this graph, for this end of the graph, it's going to keep on going slightly in that direction. So it's actually going to be approaching this second quadrant, where you have x is negative and y is positive. So we'd say as x approaches negative infinity, y approaches positive infinity. And then this end of the graph is approaching the fourth quadrant. And we'd say that is approaching x being positive and y being negative. So as x approaches positive infinity, y approaches negative infinity. And the last graph is a positive odd function. I know that because it's going down, up. It starts down, but it ends up going up at the other end of it. And so you can also tell if you multiply those together, they would be x cubed, which is a cubic function. So this one is positive and it's odd. So speaking of that, we could go back and say that this one we know is positive and it's even because the ends of the graph behave the same way and they're both going up. So this is positive and it's even. This one is even because the ends are behaving the same way, but it's negative because it's going down. So this is a negative even function. And this one, we knew right away would be odd because the ends are doing different things. And then it's negative because the overall point, like the overall direction, is going down. So it's a negative odd function. So this last example was positive and odd because overall it's going to go up from left to right. Then let's look at the ends of our graph. So this end of our graph over here is going toward the first quadrant, which is positive, positive. So as x approaches positive infinity, y also approaches positive infinity. Then this end of our graph is approaching the third quadrant, which is negative for x and negative for y. So as x approaches negative infinity, y also approaches negative infinity. So that's it for end behavior, and we'll look at another video for symmetry.